This is the topic, graphing a logarithmic function basic. And so we have this guy right here, g of x equals -3 plus log base 1/2 of x. And it says plot 2 points on the graph of the function and also draw the asymptote, then click graph a function button. Okay, so let's see, let's play around with this log base 1/2. That's kind of a little bit unfamiliar maybe, having log base 1/2. But we can still sort of figure it out the same way. So basically what we've got is our parent function is log base 1/2 of x. And then once we get that figured out what that graph looks like, we can focus on our g of x. And I'm going to write this a little bit different. I'm going to write it with the log base 1/2 of x first, and then -3. So to me, it's more obvious that we're going to take that log graph and shift it down 3. Or we'll see that we can even just subtract 3 from the y coordinates that we get from our parent function. But I'm getting ahead of myself. So, okay, let's rearrange this logarithm so that it's an exponential form. So that would be that, let's see, base 1/2 to the y, right? The log is the exponent, so to the y equals x. So we're going to pick numbers for y and then figure out our x and fill in our table sort of backwards. All right, so let's do maybe -2, -1, 0, 1, 2, yeah, I guess that's good. Okay, so if I pick -2, 1/2 to the -2. Remember, a negative exponent means take the reciprocal, so this is actually just 2 to the 2, or 4. And then 1/2 to the -1 is just take the reciprocal, so that's 2. 1/2 to the 0 is 1. 1/2 to the first power is 1/2, and 1/2 to the second power is 1/4. All right, so let's see what this graph looks like. Notice all our x's are positive, right? You can't plug in a negative number to a log, and actually you can't plug in 0 either. So everything's going to be to the right of our x-axis graph. So I need to go out to 4. Maybe I'll scale this a little bit bigger than these little grid marks. So 1, 2, 3, 4. And then 1, 2, 3, 1, 2, 3. I don't know why I'm taking so long doing that. Okay, 4, -2. So 1, 2, 3, 4. -2 is down here. And then 2, -1 is here. And then 1, 0. 1/2, 1 would be here. And then 1/4, 2. So hopefully you can kind of see that this is basically an upside down or a reflected sort of logarithm graph. Or at least from what we're used to. So this is basically, this is the reflection of y equals log base 2 of x about the, what is that thing? The x-axis, goodness. It's actually having log base 1/2 is the same as having negative log base 2, which is kind of nuts. But that it actually goes back to what am I trying to say? The power property. Gosh, I need to go back to bed. Okay, so here's our parent function. So with all that, we're now going to shift this parent function down 3 to finally graph this thing. I'm sorry, I'm taking so long. And so since we only need a couple of points on this graph, maybe let's take, I'll just take these middle ones. So I'm going to take x is 2, x is 1, and x is 1/2. And so I'm going to do, actually, I'll do it like this. For our g of x, this is just y -3. So the y that we were using over here. So 2 was at -1, 1 was at 0, 1/2 was at 1. So if we subtract 3, -1 minus 3 is -4. 0 minus 3 is -3. 1 minus 3 is -2. So these are the points that are going to be on our actual answer in Alex. So let's see. I'll use this guy for the ones that have whole numbers. So 2, -4. And then 1, -3. And then 1/2 -2, I'll put this in. But actually, I don't even need to do that for Alex. It just wanted 2 points. I'm just being a little, I guess, extra careful maybe. You can kind of think of this guy as a checkpoint. So there it is. And if I hit the graph a function, oh shoot, I forgot. Asymptote. So remember, your asymptote comes from what's inside your log. And so both the parent graph and our g of x graph have an asymptote at x equals 0. So you just set whatever's inside the log equal to 0. So shifting up or down doesn't change that vertical asymptote. So it's still going to be the y-axis. So now it should let me graph it. And so to me, I'm like, oh, okay, yeah, that looks like this thing that I graphed on my paper shifted down 3. So let's check it. All right. And so this one, it didn't ask us to type in the domain and range, but the domain is kind of the usual for a logarithm, 0 to infinity, parentheses on 0. Range is -infinity to +infinity. So let's see if there's maybe another one that has like this is a basic log base 2. I want to see if I can find one. Oh, shoot. Don't check it. Explanation. I'm in review mode, so it's letting me do this. Okay, so this will be, here's another one with a funky base so that it's going to be sort of upside down like that one was here. But with this one, after we get the parent function graph, you would multiply your y's by 2. So let's see, maybe we can do a new one. I wonder why that had an error. Okay, so I'll see if I can do this one a little faster. So let's look at y equals log base 1/3 of x. And same kind of thing, we could write this as 1/3 to the y equals x. And so if we do our table, I would pick values like maybe -2, -1, 0, 1, 2, and plug in to this rearranged version to find my x. So 1/3 to the -2 is going to be 3 squared, or 9. And then 1/3 to the -1 is just 3. 1/3 to the 0 is 1. 1/3 to the 1 is 1/3. 1/3 squared is 1/9. So then if we graph this thing, and somehow I managed to get my graph like not lining up, but that's okay. All right, sorry. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4. 1, 2, 3, 4. This is so bad. Okay, these are all like not the same distance. So 9, -2 would be like here-ish. 3, -1 is here-ish. 0 or 1, 0. So we always are getting that point for our basic log graph, no matter what the base is. And then 1/3, 1. So we can see this upside down kind of thing again because we have a fraction base. So it looks like this. And yet again, we have a vertical asymptote at x equals 0. And if we multiply the log by 2, that's not going to change that vertical asymptote. So 2 log base 1/3 x. We would just take all of these points and multiply the y coordinate by 2. So again, maybe I'll take these middle 3. So we have x and g of x. So x 3, 1, 1/3. And so I'm just going to go ahead. Okay, so -1 times 2 would be -2. 0 times 2 would be 0. And then 1 times 2 would be 2. So those would be the points that we want to plot, or at least two of those points. So I'll plot 3, negative 2. So 3, negative 2, and 1, 0. And then I need to put in my vertical asymptote. And there we go. And so if I look carefully, it does look like 1/3, 2. That looks right. It's passing through that point. So check. And there we go.